Yeah. Ooh, yeah. I am woman.
Hi, welcome back to my class in Plain Trigonometry. For today, we will take problems that will require us to apply some of the basic trigonometric functions and the Pythagorean theorem and the triangle sum theorem. You must note that the Pythagorean theorem applies only for right triangles. So for today, we will take up solution of right triangles. To solve a triangle means to find all the parts that are not given, or to find all the unknown parts using the parts that are given, and some of the trigonometric functions. For our first example, consider the following. We are given a diagram. In the diagram, there are three variables to be found: x, y, and h. This is a right triangle as indicated by this small square. We actually have two right triangles in this diagram. The smaller right triangle has an acute angle of 57 degrees, where opposite 57 degrees is h and adjacent to 57 degrees is y. And we have a bigger right triangle with the same height as the smaller right triangle, but the adjacent side, the side adjacent to 34 degrees is x. Now, using the given and a trigonometric function, we will find the values of x, y, and h. We start with the smaller right triangle. We have 57 degrees given acute angle, and the side opposite this acute angle 57 degrees is h, and adjacent to 57 degrees is y. Therefore, we will use the tangent function because if the tangent of an angle gives the value of the tangent of an angle is equal to the ratio of the opposite side to the adjacent side. We write tangent of an angle theta is equal to the side opposite theta divided by the side adjacent to theta. In the smaller triangle, theta is 57 degrees. Tangent of 57 degrees equals opposite of 57 degrees is h, and adjacent to 57 degrees is y. From this equation, we solve for h. We multiply y by tangent of 57 degrees. H is equal to y times tangent of 57 degrees. And let's call this equation 1. Now we derive another equation using the bigger right triangle and acute angle 37 degrees, and using again the tangent function. For theta now, we take theta now as 34 degrees. Tangent of 34 degrees is equal to opposite side. The side opposite 34 is h, divided by the side adjacent to 34 degrees is x. This is the adjacent side, the side adjacent to 34, or the side of the right triangle that makes the acute angle 34 degrees with the hypotenuse. So the side adjacent to 34 is x. Again, from this equation, we solve for h in terms of x now by multiplying x by tangent of 34 degrees. H is equal to x times tangent of 34 degrees. And let's call this equation 2. Now we have two values of h. From equation 1, h is equal to y times tangent of 57 degrees. From equation 2, h equals x times tangent of 34 degrees. But in these two equations, we speak of only one h. The side of the right triangle opposite 57 degrees and also opposite 34 degrees. Thus, we equate the value of h in equation 1 to the value of h in equation 2. From equation 1, h is y times tangent of 57 degrees is equal to, and this value of h must be equal to the value of h in equation 2, which is x times tangent of 34 degrees. But we cannot solve for one variable from this equation because we have two variables in this equation, x and y. Hence, we must eliminate one of these variables, either x or y, using the fact given in the diagram that x is equal to 25 plus y. Again, x is equal to 25 plus y. X is equal to 25 plus y. Hence, if we replace x in this equation by 25 plus y, the variable x will be eliminated and we will get an equation in only one variable y. We now substitute the value of x to the right hand side of this equation. At the left, we have y times tangent of 57 degrees. Y times tangent of 57 degrees equals x, 25 plus y. Because x has two terms, we write 25 plus y in open close parentheses. 25 plus y multiplied by tangent of 34 degrees. And we solve for y from this equation. To the right hand side, we apply the distributive property of multiplication over addition by multiplying each term of this binomial by tangent of 34 degrees. That is, we multiply 25 and y by tangent of 34 degrees. At the left side, we have y times tangent of 57 degrees. At the right, we have 25 times tangent of 34 degrees. Tangent of 34 degrees. Plus y multiplied by tangent of 34 degrees. Plus y multiplied by tangent of 34 degrees. To combine this y tangent of 34 degrees with this term at the left hand side, y tangent of 57 degrees, we transpose y tangent 34 degrees to the left hand side. And because it's positive, when we transpose that to the left hand side, we take its opposite side. At the left hand side, we have y tangent of 57 degrees. Y tangent of 57 degrees. Transpose positive y tangent 34 degrees to the left, it becomes minus y. Tangent of 34 degrees is equal to 25 times tangent of 34 degrees. Tangent of 34 degrees. And from the left hand side, you can see that this first term and the second term have common factor y. And so we factor out y, the common factor y, from the terms at the left hand side. Y, we factor y from the first term, we get tangent 57 degrees. Minus factor y from the second term, and we are left with tangent of 34 degrees. Is equal to 25 times tangent of 34 degrees. Now from this equation, we can now solve for y by dividing both sides of this equation by tangent of 57 degrees minus tangent of 34 degrees. We divide both sides, this left side and the right hand side, by the difference of tangent of 57 degrees and tangent of 34 degrees. At the left hand side, we have y multiplied by tangent of 57 degrees minus tangent of 34 degrees and we divide this left hand side by tangent of 57. We divide by tangent of 57 degrees minus tangent of 34 degrees. Is equal to 25 times tangent of 34 degrees. And we also divide the right hand side. We divide 25 tangent of 34 degrees by the same difference, tangent of 57 degrees minus tangent of 34 degrees. And at the left hand side, the difference of tangent of 57 degrees and tangent of 34 degrees will cancel out. Therefore, y now is equal to 25 tangent of 34 degrees 25 times tangent of 34 degrees divide by tangent of 57 degrees minus tangent of 34 degrees. And this is what we will do, compute in the calculator. Please get your scientific calculator. and the mode should be in degree, and we calculate this expression. We have 25 times tangent of 34 degrees divide by tangent of 57 degrees minus tangent of 34 degrees. And you should get 19.486. 19.486. 43588. Now we round off the answer to two decimal places. After the decimal point, you count 3, 1, 2, 3. The number to be rounded off is 6. Since 6 is more than 5, we add 1 to the preceding digit 8. And we get 8 plus 1 is 9. 19.49 meters. 19.49 meters. We have found the value of one of the three variables y, 19.49 meters, and we substitute this value of y into equation 1, where we have h equals y tangent of 57 degrees. We have h equals y 19.49 multiply by tangent of 57 degrees. We have h (19.49) multiply by tangent of 57 degrees. You should get 10.0119. Sorry, 30.0119. 30.0119. 681447. Again, we round this off to two decimal places. After the decimal point, you count 3, 1, 2, 3. The number to be dropped is 1. Since 1 is less than 5, we simply drop 1 and all the digits to its right. And we do not add 1 to the preceding digit 1. Therefore, our h is 30.01 meters. We now have values for two of the three unknown variables, y and h. The last variable to find is x, and we find x from this equation, 25 plus y, where y is 19.49, x is 25, x equals 25 plus y 19.49, and x equals 25 plus 19.49. X is 25 plus 19.49 equals 44.49. X is 44.49 meters. Now, you may want to check if we have the correct value of h of 30.01 using equation 2, because we now have the value of x 44.49. We check using equation 2. H equals x 44.49 multiplied by tangent of 34 degrees. Multiplied by tangent of 34 degrees. And we compute that using calculator again. 44.49 multiplied by tangent of 34 degrees. And you should get 30.0088391. You get H is 30.0088391. Again, we round this up to 2 decimal places. After the decimal point, you count 3, 1, 2, 3. The number to be dropped is 8. Because 8 is more than 1, we add 1 to the preceding digit, 0. Hence, our H final value is 30.01 meters, which is the same value we get using equation 1, 30.01 meters. For our next example, consider the following diagram. In this diagram, there are again two right triangles given. The smaller right triangle is a right triangle as indicated by this small square. In this smaller right triangle, the acute angle given is 63 degrees. And opposite of 63 is h. That is the height of the right triangle. In the bigger right triangle, the acute angle is 28, and opposite 28 is also h. And adjacent to 28 degrees is 125 meters. And you can see that 125 is equal to the sum of x and y. 125 equals x plus 1. And we start writing an equation using the smaller right triangle. Since the unknown variables are the side opposite 63 and the side adjacent to 63, we use the tangent function or the tangent of 63 degrees. We have tangent of 63 degrees equals tangent of 63 degrees is equal to the opposite, the side opposite 63 divide by the side adjacent to 63 degrees. And the side opposite 63 is h. H is the side opposite 63 degrees. H divided by the side adjacent to 63 is y. tangent 63 equals h over y, we solve for h by multiplying y by 63 degrees. Therefore, h equals y multiplied by tangent of 63 degrees. And we call this equation 1. Now we use the bigger right triangle with adjacent with a given acute angle of 28 degrees and adjacent side of 125 meters and side opposite the acute angle 28h. Using again the tangent of 28 degrees. Tangent of 28 degrees equals opposite tangent is the ratio of the opposite, and the side opposite 28 degrees is h. Divide by the adjacent side. The side now adjacent to 28 degrees is this longer side one whose length is 125 meters. Divide by 125. Hence, by cross multiplying 125 by tangent of 28 degrees, we find the value of h. Or h equals 125 multiplied by tangent of 28. Tangent of 28 degrees. Or h now, we find h using our calculator. We have 125 multiplied by tangent of 28 degrees. And you should get 66.463. 66.44636. 66.4636. 789. The answer is a non-terminating, non-repeating decimal number. It is a number with many decimal numbers. But we round off the final answer to 2 decimal places. After the decimal point, we count 3, 1, 2, 3. The number to be dropped is 3, but it is less than 5. So we simply drop 3 and all the digits to its right. And we do not add 1 to the preceding digit 6. Hence, the final value of h is 66.46 meters. H is 66.46 meters. Now, we substitute this value of h into equation 1 to solve for y. And after we solve for y, we can solve for x. We now substitute the value of h, 66.46, into equation 1 to solve for y. From equation 1, we have h equals y times tangent of 63 degrees. We replace h with 66.46. 66.46 equals y times tangent of 63. Y times tangent of 63 degrees. And to solve for y from this equation, we divide both sides by tangent of 63 degrees. We divide this side by tangent of 63 degrees and the other side by tangent of 63 degrees. Tangent 63 degrees from the right hand side will cancel out. And we get y equals 66.46 divided by tangent of 63 degrees. We now compute this value using scientific calculator in degree mode. We have 66.46 divide by tangent of 63 degrees. Tangent of 63 degrees. And you should get 33.863. 33.863061. 33. Y is 33.863061. 3733. Again, we round off our answer to 2 decimal places. After the decimal point, you count 3. 1, 2, 3. The number to be dropped is 3, but it is less than 5. So we simply drop 3 and all the digits to its right. And we do not add 1 to the preceding digit 6. Thus, our final value for y is 33.86. 33.86. Our unit is meters. Now we can solve for x by writing the sum of x and y equals 125 meters. From the diagram, you can see that 125 is equal to x plus y. We write that equation, x plus y, the sum of x plus y is 125. This is a linear equation in two variables x and y. And we transpose y to the other side because y has a value so that it can be combined with 125. And we get x equals 125. Transpose positive y to the right, we get minus y. Or x equals 125 minus y, 33.86. And we find this value using our calculator. We have 125 minus 33.86. And you should get 91.14. 91.14 meters. That completes our solution. We have found all the values of the unknown variables in the diagram. X is 91.14 meters. Y is 33.86 meters, and h is the first variable we found is 66.46 meters. For your practice, please try the following exercises. These problems are very much similar to the examples we just have today. In number 1, we have the right triangle with acute angles 58 degrees and 33 degrees. The unknowns to be found are x, y, and h. In the second right triangle, this is 19 inches. The acute angles are 27 degrees and 47 degrees. The variables to be found are x, y, and h. In the first right triangle, the acute angles are 33 degrees, 58 degrees. This is 39 inches. And we have two right triangles in this diagram. The smaller right triangle and the bigger right triangle. In number 2, the acute angles are 27 degrees and 47 degrees. And this is 19 inches. Again, we have two right triangles in number 2. The smaller right triangle with the given acute angle 47 degrees. And the bigger right triangle with acute angle 27 degrees. And that completes our lesson for today. We will have more examples for solution of right triangles. In this example, we only made use of the tangent function, but in the next examples, we will use other trigonometric functions as well as the Pythagorean theorem and triangle sum theorem to solve right triangles. If you have questions about the lesson today, you ask your questions in the comments below. And don't forget to ask your friends to subscribe to my YouTube channel, Art Kalisan. Thank you.
Yeah.